Homework number 7. What's 1/3? Do you remember like what 1/3 becomes as a decimal? If you go 1 divided by 3, what do you get? Yeah, it's 3's forever, huh? You with me? 3's forever? The 3's never stop, do they? What do we call that? We call that a never-ending decimal. That's not really what we call it. I mean, that's more casual. Its formal name is non-terminating decimal. It's a decimal that doesn't terminate, doesn't end. It goes forever. So that's a non-terminating decimal. How do you write it? How do you write 1/3, which is 0.333 forever? How do you write it in the lingo? The bar, huh? You guys remember that? When you put the bar over something, the 3's means it goes forever, doesn't it? So there's our answer, C. We good on that? Okay, let's go to, actually what's funny is B would be the same thing, wouldn't it? But nobody writes it. If you done to write something twice, it's going to repeat forever anyway. So people don't write it that way. All right. Yeah, I have a trick question for you. You guys up for a trick? You feeling tricky today? How much is 0.9 bar? What do you mean? 0.9 bar. I mean, what does the bar mean? Nine's for how long? Forever. You ever thought carefully about forever? It's an interesting concept. 0.9's forever. That's really close to what number? 1. It's pretty close to 1, isn't it? Just 1, like 1.0, like 1 right on the money. Pretty close, huh? How close? Very close. Wait a minute, it's very close. Well, I just wrote that it's equal to. You see that? Like exactly equal to. That's what that means. Am I making errors?
Yeah, because it'll never reach 1.
What's that?
It'll never reach 1.
So it'll never reach 1, so it's not exactly equal to 1, right? So what I wrote up there is wrong. No? It is exactly 1. It's not just close. It's exactly 1. Do you believe me? Just because I'm the math teacher, I got to be right? Whatever. Say whatever you want, Mr. Heron. 3 is 2. We'll take it, write it down, put it on a test. Let us out the door. We're good. No, really though. Really. 0.9 bar, 0.9's forever, is 1. It's not just close to 1. It is 1. It's exactly 1.0. It's not a smidge different. Now, I can prove it to you. Now, when I say proof, I don't mean I'll show some fancy thing that you won't understand at all, and you'll say, well, he said so, so all right, whatever. No, I mean I'll show you a way where you will understand very clearly and go, oh yeah, that's got to be. That's what I mean by proof. Where you will agree on your own. You can show people. Think with me, we just did it. What is my pin's coming out here. What is 1/3? We just did it, right? What is 1/3? 0.3's forever, right? So how much is 1/3? What if I said, hey, I ate 1/3 of a pie, and then later I had another 1/3 of the pie, and then after that I had the last 1/3 of the pie. How much pie did I have? 1 whole pie. Close to 1 or right on the money 1? The whole pie, right? What do these equal? What do each of these equal? 0.3's for how long? So if you add these all up, what are you going to get? True. Right? And you agree now, huh? That's a proof. That's what a proof is. Where you show somebody with simple steps that something they didn't think was true is true. You can tell I get excited about it. That's why I majored in math, not that dumb little one. But in general, I like good logic thinking that surprises you with the result. To me, I love how logic can take you places you wouldn't have thought before. Clear, that's why I majored in math, not because I like moving X's around. But I like good, clear, logical thoughts. I think I enjoy that kind of thing. So this is one of the things I enjoy. That it's true. It's true, isn't it? It really is. I'm not pulling sleight of hand mathematics today. It is true. It's not. I'm not just fooling you. Go on Google. Google knows. You can go on Google and say 0.9 forever, but I'm sure there's a million things on there about how it's the same as 1.0, and they'll tell you ad nauseum, on and on and on about why it's true. But I'll just keep it simple. That's a simple proof, isn't it? Right? 1/3, 1/3, 1/3 is a whole. This is 0.9 forever. The fact is, you might think, well, wait a minute. It might disturb you a little bit. You might think, no way. 0.9 forever, it's not 1. It's close to 1, but it never reaches 1. Well, let me satisfy that feeling that you have. I'm sure you have. I had that feeling too. For everybody does. When you first see this, that's why you go, what? No way. Let me help with that feeling. If you're looking at that going, it's 9s. It's not 1. It's not 1.0. It's close. It can't be true. Well, the reason it is true, actually, is because the 9s go forever. If they stopped after 10 million 9s, then there would be a difference. But they don't stop. They go forever. And that's where the forever is tricky. Let me show you. Here's one more proof. I'm probably using a all the time. One more proof. If this is what you could say to your friend. Do you talk about math with your friends? Maybe you should. If your friend said, no way, no way, no way. I've had people say that to me. No way, no way, no way. Those are not the same. I would say, okay. If you're telling me they're different, if two things are really different, then you can subtract them and get a difference, right? Like 7's not the same as 3, because if I subtract them, I get 4. That's how different they are, right? So what happens if you subtract two things and get 0? What does that mean? They're the same. Don't we all agree? If you subtract two things and get 0, they are the same. So I would say to somebody who swore to me, no way, those are different. I would say, okay, if you tell me they're different, then you subtract them. Let's take 1.0 minus 0.9s forever and find out what we get. Now, you think, well, I can't. The 9s go forever. How am I going to subtract? Right, I hear you. So let's just do it step by step. What if there was just one 9? Just 1.0 minus 0.9, just 1 9. Well, that'd be easy. It'd be 0.1. That'd be the difference. And they would not be the same number. 1.9 is not the same as 1.0. Agreed. But there's not 1 9s. There's not 1 9. The 9s go forever. Okay. But what if there were 2 9s? What would be the difference then? $1 minus 99 cents? 1, right? Right. If there was only 2 9s, that would be the difference. But there's not 2 9s. The 9s go forever. Okay. What if there were 3 9s? Well, 001 would be the difference. If there were 3 9s, there would be a difference, and those are not the same. But there's not 3 9s. The 9s go forever. Okay. What if there were 4 9s? You get the pattern, right? It'd be 001 if there were 4 9s, but there's not 4 9s. The 9s go forever. All right. So you get the idea. Let's just do the etc. now, right? The 9s don't stop. If they stopped after 10 million of them, they don't though. The 9s go forever. So when does the 1 come? At the end, huh? The 1 finally comes at the end, right? When is that? When does that 1 come? After how long? How many 9s? After how many 9s? After forever. What if I said, you know what? I'm feeling generous. I'm going to give everybody $10 for lunch. I'll give that to you after forever. What does that mean? That means there's no $10 coming, huh? So when is that 1 coming? After forever, right? Forever 9s. That 1 comes after forever, which means it doesn't come. So what does that mean is the difference between those two numbers? 0, which means those two numbers are the same. There's a second proof. There's others. I got to go on. That 1 is 0.9s forever. They are the same. There is no difference. Because the forever slips into the next spot. Isn't that weird? The fact that the 9s go forever makes it slip into 1.0. We saw it logically. So what does it mean to have a bar? Again, what's that bar mean? Just keeps and repeats that. It repeats whatever's under. Notice the bar's not just over the 8. It's the whole 18, so it's going to be 18, 18, 18 forever. Right? They could do it like this, huh? This would be a different number, wouldn't it? That would be 2.1 and then the 8's forever. Everybody see the difference? So whatever the bar's on, that piece however many digits repeats, right? Okay, great. So what? Can I change that to a fraction? Do you know? That's what they want from me in this problem. They want me to take this decimal number, either one's fine, and change it to a fraction, like a number over a number. How do you do that? How do you make that thing a fraction? Well, since time is running, let me give you a shortcut, and I think it'll be good enough. Unless something comes up later, I'll show you the longer way, but might as well keep it short if we can. It's going to be 2, and whenever you have something over a bar, like 18, it means over that many 9s, it turns out. I think, I don't remember your math teacher saying, I think. Is that true? You guys have a calculator? What's 18 divided by 99? Isn't it 0.18s forever? Somebody have a calculator? Oh, I got this little silly cell phone calculator here. It is, right? 18 over 99? Yeah. Okay, yeah, it's true. So you just pop it over 99. That'll make it do the 0.18 for everything. Now, that fraction is actually reducible. What can I divide top and bottom by there? What goes in 18 and 99? 9, huh? So this becomes 2. 18 divided by 9 is 2. 9 divided by 9, 2 11. So there we go. That's mixed number. I don't know if they want mixed number or improper to improper. So you know how to change it to an improper? Remember, you multiply the bottom number, add the top. 2 times 11 is 22. Add 2, 24 11s. There it is. We'll finish more of this later.